0 to pi limits are there, both having 1 powers. It will be 1 plus 1 gamma 1, because 1 plus 1 upon 2 means gamma 1 only, where twice gamma 1 plus 1 2 plus 2 4, 4 upon 2 fact gamma 2. This is integration of this value. Okay, whenever this value is there. Now second point, this minus 2b square. This can also be integrated. This is cos square phi. Integration of this when 0 to pi by 2 is there, reduction formula. It will be 1.2 into pi by 2. Integration of cos square phi. Similarly, minus 2a square. Minus 2a square sin square phi can also be integrated in the same way. It is also 1.2 into pi by 2. 2a sin square phi. Minus 2b sin phi 2b square minus 2b square sin phi cos phi can also be integrated by the gamma function. This is 1 power mn, and both are, it is 1 plus 1 upon 2 means gamma 1 upon twice gamma 1 plus 1 2 plus 2 4, 4.2 is gamma 2, just like we did this sin phi cos phi. So this is also integrated. Now these two with plus sign here, plus 2a square. Okay, both having the similar integration. If I write it as 2a square plus 2b square, no problem if I write. And these two are integrated in the same fashion, because this is m is 2 here, n is 2, n is 1 here, n is 2 here, both having similar terms. What is that? First will be 2 plus 1 3 by 2, gamma 3 by 2, and 1 power is this, so gamma 1 2 by 2 divided by twice gamma 2 plus 1 3 plus 2 5 by 2, so gamma 5 by 2. This is both, but this is also 1 plus 2 3 plus 2 5, 5.2 gamma in the denominator. So these two are simultaneously differentiated, but both we have differentiated, sorry, integrated sin square phi cos square phi by gamma function. Integration is 0 to pi by 2 limit. Whenever 0 to pi by 2 limits are there, so gamma function is integrated easily. Okay, all this is to be now summarized. Let me take what are the values. So finally, integration of this will give us summation of them. Let me write is pi a square b square upon a square plus b square whole power 3 by 2. This is volume we are calculating. Now pi by 2 minus pi by 2 0, cos pi by 2 is 0 first is, but when we minus for the lower limit, then minus sign is also put. That will be 2a square positive only, because cos 0 is 1, but with the minus plus it will be only 2a square positive value. What the point? Minus cos phi is integrated, is put the limits here. First pi by 2 minus cos pi by 2 is 0, but lower limit when we substitute 0, the lower limit is 0 here. So when we put the lower limit, we put minus sign in between. So minus plus cos 0 is 1, which is plus 1 into 2a square, 2a square only. In this case, sin pi by 2 is 1. So this is 2b square only. 2b square. What the point? These two are now done. What about this minus 2a square and this? This is minus 2a square. Gamma 1 is 1, and 2 gamma is factorial 1, that means 1 only 1.2. This is only minus a square. So this is minus a square here, because upon 2, this 2 will come here. This is minus 2b square, and this is pi by 2, and 2 cancelled out, so 2 to cancel out here. Only pi by 2 into b square, this value is pi by 2 into b square. Second is again pi by 2 a square minus a square into pi by 2, minus pi by 2 into a square. That means a square plus b square we can take common from here also. These two are done. What about this one? This 2 to cancel out. Again, this is also the same. 2 to cancel out. Only b square here. But gamma 2 is factorial 1, that is 1. This is minus b square here. cancel out. This is minus b square here. Okay, now this is 2a square plus b square. Last quantity. 2, if I take common, this is a square plus b square. Now here, for this 2 to cancel out, let me first solve it. This is gamma 3 by 2 is 1.2, gamma 1.2 in the numerator. In the denominator 5 by 2 is 2 into gamma 5 by 2 is 3 by 2 into 1.2, gamma 1.2, gamma 1.2 and 1.2 cancel out. This 2 to cancel out, 1.3, 2 by 3 here. Okay, so this is 2 by 3 only. Now let me rub this over. Now this is finally solved, but let me summarize further. This is pi into a square b square divided by a square plus b square whole power 3 by 2. This twice a square plus b square 2 if I take common a square plus b square here. Now this minus a square minus b square means minus sign can be taken common. It is a square plus b square only. And this is pi by 2 here minus pi by 2 common. A square plus b square, both are now plus sign. A square plus b square. Here it is plus twice a square plus b square upon 2. Okay, this 2 upon 3 only. This 2 by 3. 2 upon 3. So these are the values. Now a square plus b square we can take out. It will come out. It is pi a square b square upon a square plus b square whole power 3 by 2. Now a square plus b square we can take outside. So this is 2 only. 2 minus 1 here, this value. So minus pi by 2 from this plus 2 by 3. 2 minus 1 is 1. 1 plus 2 by 3 is 5 by 3. 5 by 3 minus 5 by 2. Okay. And this 1a square plus b square is cancelled out in the denominator. In the denominator we will get only under root a square plus b square. Finally, what is the value? Let me write here. Therefore, final value will be volume is equal to pi into a square b square upon, now this 1 power a square b square cancel out in the denominator, only under root a square plus b square will be left over. Within bracket, this is 2 minus 1 is 1, 1 plus 2 by 3 and minus 5 by 2. This is 5 by 3. 3 plus 2, 5. Okay, so this is pi a square b square upon under root a square plus b square. In bracket it is 5 by 3 minus 5 by 2. This is the same answer. Question number 8. Pi a square b square upon under root a square plus b square into within bracket 5 by 3 minus 5 by 2. Same answer is obtained. Hence proved. So the same value is proved. The volume of the solid obtained by revolving this arc AB around the line obtained by joining the extremities of the major and minor axis. Okay, 2 extremities, 1 extremities of the major and minor axis. So this solid is having this volume. This is the same volume which we have obtained here, pi a square b square upon. We have to prove. We had to prove. Now we have proved this. So pi a square b square upon under root a square plus b square into within bracket 5 by 3 minus 5 by 2. Simple. This is the question number 8, which is very good question, systematic. But this is okay. One of the type 6 and 7 also of the same type we have discussed already. Okay, so in the 6, 7 also there was a solid revolve around a line which was other than the axis. So when other than axis a line is there and a solid is obtained by revolving about that line, then the formula we have applied is pi into pn square into d into an or on, whatever the line is. Okay. Now let me take the 9th question. Now question number 9 is of 3-dimensional figure, double integration. Now double integration we are using here 9th, question number 9th onwards. What is double integration and how to find the volume in that situation? Let me just write here first and then I'll just first let me define. how the volume of a solid in or double integration with the help of three-dimensional figure by double integration. How to be obtained by double integration? How this formula is obtained? So first of all, let me draw the three-dimensional figure. It is having octants here. There are 8 parts here. Suppose this is x-axis, this is y-axis, and below this is z-axis. Suppose there are 4 parts in the space here. This is the line. Suppose z-axis is this, and here it is x-axis. This is the y-axis. Okay, then with the x-axis and y-axis, we know that there are quadrants. 4 parts are here, and z-axis will also divide one part, other part, and in this way 4 parts in the with the z in the space also, 4 parts in the on the plane also. So 4 and 4, 8. So there are 8 parts when 3-dimensional geometry divides. This is x-axis, y-axis, this is z-axis. We have taken in clockwise direction. Okay, in clockwise direction we have taken x and y and z. Now if I take the 3-dimensional figure here, so this is of this kind, a plane of different planes here. The first octant here, this is let me take this is the first octant here, x and y plane. In this case, z equal to 0 in this plane. Here y is 0 in xz plane, and here in yz there is x0. In this case, if I take the x0, then draw a line parallel to x-axis and make a cylinder here, cylindrical, and this area will be dy dz, and this is x coordinates. Therefore, volume of the solid obtained in the plane z x equal to 0. So the volume of the solid in the plane x equal to 0 is given by double integration volume into, in this case, x into dy dz. This is the volume here. And in the plane y equal to 0, in the plane y equal to 0 here, in this case x and z plane. In the plane y equal to 0, what is the volume here? Volume is equal to double integral. Here it is y into dz dx. Or we can write dx dy. Okay, but after y we take z, y z x. Okay, in this is systematic manner. Okay, then in case of plane z equal to 0, and in the plane z equal to 0. That means this is the plane here, xy plane. In the xy plane, the volume of a solid obtained by revolving that plane, okay, around that plane, z equal to 0. Here z equal to 0, the volume will be z into dx dy. Okay, so this is the 3 solids obtained in the three octants here we have taken. But octant, if is there, one single octant, if the whole area, whole volume is to be calculated in all that 8, we have to multiply this by 8 then. 8 into this volume in one octant. This is one of the octants here, where the plane area, the plane xy, which will form the octant here, because z is 0 here in this case. Similarly, y is 0, z 0. In this case also we draw a solid here in this case like this. This is the solid here. Okay, this is parallel to the generator of this are parallel to the z axis. This is z here, and the plane here is dx dy. The area of the base is dx dy into z. This is z into dx dy. This is the third solid obtained in the plane z equal to 0. Okay, so this is the process here. Now let me take 9th question. What is the 9th question say? That we have to find out the volume of a solid which is in 3-dimensional figure. Let me take that here. Now question number 9 says, find the double integration here. We have to apply now double integration. Double integration is applied like this. Okay, limits we will find whatever the limits are there for x and y that I'll just define. Double integration. Find the volume of the ellipsoid x square. Okay, to find the volume here the curve given is ellipsoid. Curve is ellipsoid. The ellipsoid here x square upon a square, y square upon b square, z square upon c square equal to 1. So this is the ellipsoid which we have obtained here. Okay, sorry, equal to 1. Right? Z square upon c square equal to 1. Now this is double integration. Find the volume with the double integral. Find the volume of the ellipsoid this. Now this ellipsoid we have to find the volume. And the volume of this ellipsoid, well, let me take in the plane solution here. So we have to find the volume of the solid. Now if I put okay z equal to 0 in the plane, z equal to 0, you will obtain what? Now in the plane z equal to 0, what we obtain here? Just z0, this term is 0. Therefore, the equation of the ellipse will be in this case, because in this case we have to find out the equation, the volume of the, find the volume of the ellipsoid. Let me first find z equal to 0 here. Okay, if I put z equal to 0, then as z into dx dy we will find out. But before that, let me find the equation of the ellipse will turn as x square upon a square plus y square upon b square equal to 1. That's equation. That means y square upon b square equal to 1 minus x square upon a square, or y square is equal to b square into a square minus x square upon a square. Okay, or y is equal to b upon a under root a square minus x square. So this is the value limits for y we have to substitute. Okay, if I put y 0 here, so limits for y are 0 to this. Now limits for y, therefore limits for y will be y equal to 0 to y equal to this value. This is b upon a under root a square minus x square. Okay, so this is the value here. Now let me find the volume of the solid in the plane z equal to 0. Therefore the volume of the solid in the plane I am finding out. Okay, this is one of the positive octant I am taking of the volume of the solid in the positive octant. Let me take positive octant here. The positive octant where z equal to 0. Z equal to 0 is given by double integral sign. Limits or x limits will be what? When y is 0, x will be 0 to 1, because if I put here y 0, let me take, so x will be a square in that situation. So x equal to 0 to a. Here x equal to 0 to a. Y equal to 0 to b upon a under root, this is a square minus x square into z into dx dy. There it is. Okay, dx dy. Now let me put the value of z. Value of z is in that situation. What is z here? Z will be under root of this 1 minus x a square from b square. Now let me substitute the value of z in this equation. What is the value of z in this case? This is given by x equal to 0 to a, y is 0 to b upon a under root a square minus x square Z will be, now if I put Z equal to, if I find, that will be 1 minus x square upon a square minus y square upon b square whole square root. Z is equal to into c. Why c? Because z upon c square, z square upon c square equal to 1 minus this whole. Therefore, z equal to c will be there. C will be square root into dx dy. Dx dy. Now I have to solve this. If I put y upon b is equal to under root of this value in sine theta, then it can be resolved. So putting here, putting 1 minus, or let me take y upon b is equal to, because this is y upon b whole square. Okay, so y upon b is equal to, if I put square root of 1 minus x square upon a square into sine theta. Y upon b, putting y upon b, this y upon b is the whole square of y upon b. So y upon b, if I substitute under root 1 minus x square upon a square into sine theta, then dy will be equal to b into under root 1 minus x square upon a square into cos theta into d theta. It will be dy equal to, what are the limits in that situation? So limits for this y here. When y is 0 here, sin theta is 0. So this whole divided by 0 upon something 0. Sin theta is 0 means theta is 0. At y equal to 0, the lower limit, theta equal to 0. And at y equal to upper limit b upon a, if I put here b upon a, here also this is b upon a, y is equal to. If y is equal to b upon a, or even if here I put b upon a, so b cancel out, this is 1 upon a, the same value will be obtained. Okay, so that means sin theta will be 1, or sin theta is 1 for sin pi by 2. So at, let me take at theta at y is equal to, this is y here, b upon a under root a square minus x square. If I substitute here, it is also same thing, because a square minus x square upon a, that will be b upon a under root a square minus x square, this value is. The same value is put here. This upon this is 1, sin theta is 1, therefore theta is equal to pi by 2. Upper limit is pi by 2. Okay, if I substitute them, now let me put here. Therefore, the volume is, now change this formula into, first is x0 to a. Now y is changed as terms of theta. What is y here? 0 to pi by 2. Now this value, okay, in this case I have substituted y equal to this, but here under root 1 minus x square, that will be taken common. So it is now 8 times answer. Volume here is, this is one of the octant here. So I have to multiply this by 8. Why I have to multiply this by 8? Because it is 8 times here. Okay. So 8 times I have to multiply this with 8 times. 8 times, because this was one of the whole volume we have to find out of the ellipsoid. That means it's a spherical type. This is whole volume we have to find, double integration, find the volume of the ellipsoid this. So total ellipsoid we have found. This is one of the octant here. If I, let me take first one of the octant, then total volume will multiply by 8. Doesn't matter. That is 8 I will multiply last. Okay, in the last I will multiply by 8. So this is 0 to pi by 2. What about this value? Here c is there, but here we will substitute here y is equal to b upon a. Okay, if I substitute here y upon b, in y upon b is this value, that means if c is out, let me take here c. C is out of this bracket, and here it will come out as 1 minus x square upon a square. Why? Because under root 1 minus x square upon a square, and this is also 1 minus x square upon a square into sine theta, sine square theta now. And this is square root cancelled out. So this 1 minus x square upon a square, square root will be taken out. This will come out like this. Okay. And then The C was out here already. So in by upon B, I have substituted, or y equal to b upon a here. Then b we cancel out. So this value total is under root 1 minus x square, and this under root b into under root 1 minus x square into this value is also will come out. This is b into c here. This is b into c. So this b under root 1 minus x square upon a square, and from this square root 1 minus x square upon a square common will be taken under root 1 minus x square upon a square, because here also after square root only 1 minus x square upon a square will come, square root of this will come out, that square root and this is square root d by, okay, the value of d by is in terms of d theta, cos theta d theta, this cos theta, and from this square root 1 minus sin square theta will be obtained. So this is under the square root, bc I have taken, so this b here, value of y, value of d by here, value of d by is this b into under root of this value, okay, that is there. In this case 1 minus x square upon a square is taken out into 1 minus now sin square theta into cos theta d theta, this cos theta d theta, and this value b under root 1 minus x square upon a square is taken out. This b are taken out. Now in this case, now let me solve it here. So further it will be now cos square theta. Why? Because cos theta will come out from square root, from this square root. Cos theta and this cos theta is cos square theta. This is bc into 0 to a, 0 to pi by 2. This is pi by 2 here. In bracket it is 1 minus x square upon a square. Okay, that we have substituted now. Now this is cos square theta into d theta. Why cos square theta? This 1 minus sin square theta is cos square theta. Square root cos theta, okay, will be there. This cos theta and this cos theta is cos square theta. Now with respect to theta, limits are 0 to pi by 2. We have to integrate this value. It will give us bc into 0 to a now, 1 minus x square upon a square as it is, into this, sorry, d theta dx is also coming, I am sorry, dx is now left over, dy is only converted into d theta, but dx was there, so this is dx here, into integration of cos square theta d theta by reduction formula 0 to pi by 2, limits are there, since 0 to pi by 2, let me write here, cos square theta d theta is equal to how much? This is 1.2 into pi by 2. This is 1.2 into pi by 2. So this pi square upon 4, sorry, pi upon 4, that let me take outside. So this is pi upon pi bc upon 4 here, I have taken outside. It is to be integrated 0 to a into 1 minus x square upon a square into dx here. Now what is the final value of this equation? So it will give us now integrating this with respect to x here. What this will give us? Now let me write here. Finally, the volume will be pi into bc upon 4 we have obtained here. So this pi upon 4. Pi bc upon 4. Now integration of this 1 is x minus x cube upon 3 a square is as it is. Integration of x square is x cube upon 3, x power 3 upon 3. A square is already there, into limit 0 to a now for x. So this is to be integrated. Now sorry, value is to be substituted of x here, upper limit is a, only a will be substituted because at 0 it will be 0. It is nothing but pi bc upon 4 into, so this is a minus a cube upon 3a square, so 1 a is left. This is pi bc upon 4 into a minus a upon 3, that means 3a minus a upon 3. So this is twice abc, twice a upon 3. It will be 2 pi ABC upon 3 here. Is it 3 for the 12? 12 here. Now this is of 1 octant, 1.6. This is pi ABC upon 6. This is of 1 of the octant here. This is of 1 octant. 1 octant. But we have to find out of the whole ellipsoid. Therefore, volume of the whole ellipsoid, all the 8 octants. 1 octant is 1/8 part. The volume of the ellipsoid, therefore, volume of the whole ellipsoid will be 8 into pi ABC upon 6. That means this is 2 4 ja, 2 3 ja. 4 pi ABC. This is 4 by 3 pi ABC. This is the volume of the ellipsoid here. 4 by 3 pi ABC. Pi into ABC. Okay, so this is the volume answer here. It was 8 upon 6. That means 2 4 ja 8 and 2 3 ja 6. 4 by 3 pi ABC. This is the volume of the ellipsoid in this case. Okay, so this is the volume of the ellipsoid. Question number 9 is done. Now let us talk about next question. The answer of ellipsoid is 4 by 3 pi ABC. Pi into ABC. Whole ellipsoid this is. 4 by 3 pi r cube we say. 4 by 3 is okay because volume of the solid or a sphere is 4 by 3 pi r cube. If it is A, B, C are converted into 1 unit, then it will be A into A into A 3 times. So 4 by 3 pi A cube. That is the same answer, pi r cube, volume of a solid. So this is the same answer which we have obtained, or ellipsoid, which is a spherical shape in the 3-dimensional figure. Okay, the volume of the solid is there. Now question number 10. Let me solve it. Question number 10 is here. Find the volume of the sphere. This again, a sphere is given to us. Okay, a sphere is x square plus y square z square is equal to a square. I'm sorry. This is a square. Let me take first equation to find the volume of this sphere. To find the volume. To find the volume of this sphere. Okay, so that we have to do in the same way by double integration. Let me find out this. Let me change the marker.